Hi guys, I'm going to talk you through how to find the standard deviation with this example. So the first step is to find the mean of all of the data. So to find the mean, you add up all the numbers and divide by the number of numbers. So our mean is 1.49. Now you need to find the difference between each data point and the mean. So here is each data point, and from each one I subtracted the mean. So this first gymnast was a little bit shorter than average, so that gives me negative 0.042. Same with the second one, negative 0.022, and I did that for all 9 data points. So I want the average of these differences, but if I took those averages right now, my negative differences, all the places where the gymnast was a little bit shorter than average, would be canceled out by all the places where the gymnasts were a little bit taller than average, because I have negatives and positives in this. I don't want negatives and positives, so I'm going to square each of those differences. That means I just multiply it by itself so that all I end up with are positive numbers. Then I got to take the average of that. So I added up all those tiny numbers, divided by 9 again. But I know that's all of my values squared. I need to undo the squaring. So the opposite of squaring is taking the square root. So I take the square root and I end up with this number, 0.065959, and it went on and on and on. So that means the standard deviation is that, and I'm going to round it to 0.066. So my original question was, is our data normal? Our standard deviation tells me to expect a difference from the mean of about this much. So I'm going to look at our mean, our median, our mode, which we found earlier. The difference between the mean and the median is only 0.002. The difference between the mode and the mean is only 0.04. Both of those are much smaller than our expected difference, our standard deviation, which is 0.066. That means our data is normal. I know it was a really long process, and frankly, it looks way worse as a formula. This is everything we just did. But that's why you have to use the stats calculator that I linked in our last class, because it's going to do all of those computations for you in just a split second. And there's only one last thing to know about standard deviation. There are 2 types. There's population and there's sample. The sample formula, this one right here, it corrects for the fact that you don't have all of your data. So it knows you're only taking a sample, and it gives you a bigger standard deviation so that there's a bigger range of what an expected difference is because you don't have all of the data. The population standard deviation formula looks almost the exact same, but they have a different symbol for mean, and they only divide by the number of numbers, not n minus 1. You can tell which one you need to use based on what the question says. If it says it's from a random sample, where you see the words like sample mean, that means you're using the sample standard deviation. If it would be easily possible to get all the data from the population, you use the population standard deviation. If it wouldn't be, for instance, if you're trying to find something for thousands of people, you would use the sample because there's just no way you could get to all those people. I hope this helps. Be sure to try these before you click to the next slide and see the answers.